So I don't think we've seen any technology conference these days that doesn't use the word blockchain or cryptocurrency. And of course, we will do the same. We wanted to have that part of the conference here as well. And we're talking about cloud encoders. We're talking about on-prem encoders. I think Philipp now will reveal something completely different where we have distributed encoding coming out with blockchain technology. So welcome, Philipp Angele from Livepeer.
Thank you. So today I want to tell you about shared economies for video infrastructures. So there is a new infrastructure becoming available for those who want to run video platforms at scale. And the main advantage we see for them is saving costs along the way, especially with the long-tail content part. So it's expensive, especially the transcoding part, as you have to do all these efforts before a single user could watch it. So you don't even know if you will have any income stream from this at all. Companies like cloud computing providers, they make it affordable to start with, but they keep it really expensive to scale it up. So in many cases, it is like renting the infrastructure from your competitor. If you want to create the next YouTube, it's really hard then to go to Google Cloud and build all your infrastructure there, or use all their infrastructure there. And that's also meaning that you're going to drain quickly through your funds. It's not really giving you a leeway to find a business model. Most startups experience this problem. They have a finite amount of money, they start with their innovation, they have a sudden success, all for a sudden many people are consuming their content, but they are quickly running out of time to find a business model as they're just running out of funds. And that in the end is forcing all these startups to really early on tax their users with either like selling their data or bombarding them with ads. So the underlying problem here is really the infrastructure cost. It's owned only by a few companies, and even so there is competition between these companies. For a new player in that market, it's really hard to get a significant market share without also doing the same investment in the infrastructure. And with Livepeer, we think on how to break this paradigm. Is there a way to break through this cycle and find a new independent infrastructure? And our research revealed that there's peer-to-peer open source software available to build completely decentralized video platforms. And that has the potential to form a completely new infrastructure. But the problem is it's kind of unreliable, right? You never know how users are what connectivity they have, and how could a video platform that's applying these technologies then compete with the centralized offerings. If the user has a bad user experience by using it, they simply can't. There's no chance they can't. And what's really missing for them is a dedicated infrastructure layer that they can rely on. So what we try to do now is we're trying to reach a new higher efficiency and productivity in these type of workflows. And we do this by building an open marketplace in which anybody could trade encoding resources with each other, and anybody could participate in such a marketplace. And it's a problem to do these things in public networks because you somehow have to validate that the work in such a network is properly done. And we use the Ethereum network to do the validation and the accounting for all these tasks. So for those of you not so familiar with what smart contracts are, there's basically a piece of code that's running on the blockchain, and it will always exactly execute as it's programmed. So that's introducing trust between two parties, right? They can trust however this is being programmed, this is going to be executed. And nobody can cheat each other in such a scenario. And there's no middleman required that would act as a gatekeeper. And in the end, it will work like this, I send you encoded VD, and you send me payment, and nobody can screw each other. So this can minimize the underutilization of existing infrastructures by having these companies sharing it with each other. But this still would require a set of dedicated hardware, right? Somebody has to host the servers there. And to really gain a completely new productivity, to increase the productivity and efficiency, we want to add cryptocurrency miners to that picture. So cryptocurrency miners, they're all over the planet. And in total, you can estimate about 10 million graphic cards being used for the task to create these new digital currencies. And all of these cards, they have little chips inside that could be doing video encoding, and they're completely not in use currently with the miner software. The miner software is dedicated on the reprogrammable compute units in the graphic cards, and all the graphic cards now have ASIC chips inside that really can do only video encoding, mainly to do game streaming and to enhance your playback experiences. So this gives them a kind of unfair advantage to anybody who wants to use like dedicated hardware on the task, because they don't have to pay anything for housing or for the hardware itself. It's already running in a working business model. It's already paid off in many cases. Many of these miners have invested last year during the bull market and were able to pay off such a rig within just a month or two, if they sold their coins. But now this is still continuing. These cards are still actively processing, hashing cryptocurrencies, and we are looking to basically give them a second use. The encoding technology can run side by side to the actual cryptocurrency hashing technology in these graphic cards without interfering each other. So it's a second use, and so a second income stream that we are trying to create. So of course, you have to make sure the technology behind it is doing it. It has to validate well in a public network. And in our case, for live streaming and VOD encoding, it means like, can you prove the video hasn't been tampered during the encoding? Like, did you change the picture itself? What's like the video quality of the output? Did somebody try to simplify the encoding task? And how's the performance of the stream? Did he stop delivering midstream? And what we did, we created a video fingerprinting system, or basically we're using research out of the Mozilla Foundation that's using PSNR to do similar tasks in a different fashion. And we were able to utilize this to create these video fingerprints to really test now, is it a proper encoding job? Is the codec, the frame size, bit rates, is this accordingly to the job settings? Then is the tamper-proof? Has somebody changed parts of the picture? And what's the quality estimation score? So this is being done by PSNR, very similar how Netflix is trying to figure out their quality improvements, or how they did it before they invented VMF. So we're trying to enforce a competition between the participators in such a network. We call that a transcoder race. So first, we only wanted to solve the unreliability issues in peer-to-peer networks. Nodes come and go, and furthermore, they should be allowed to fail. They should be allowed to go offline at any time to make the overall network work. And now to do this efficient, like to have multiple transcoders and electing the transcoder that would then do the job well, we are creating a kind of race condition among them. So we have multiple workers that try to apply for the same job, and we allow them to do a small part of that job and measure their efficiency, measure their productivity and quality. And by doing so, we are able to, from a group of workers, always pick those who are the best for the job. So the result is a competition on quality and on reliability. And that creates then a high availability network that has then like an economic incentive to be like the best worker, as we only pay the best worker for his work. Our marketplace, so we had to create a marketplace for such a thing, so that they could trade directly with each other. Livepeer, it's a completely open source technology. We don't even create a fee market on top of it. So basically with that open source technology, it's a marketplace that everybody can now trade resources with each other without a middleman, even without Livepeer as the middleman. And we split in our design, we split things up in 3 pieces. So we have the broadcaster, that's the buying side of the encoding sources. Many of you in this room maybe. So they would buy the encoding resources from the network, and they would be able to validate how well it was being done. And we have orchestrators who bids on the available work on the network and manage the transcodings among various transcoders. So the transcoders, the orchestrators, and the broadcasters form a kind of botnet with each other. It's a trading botnet where you have the buying side, the orchestrating side, and the working side. In our case, the broadcaster would reach out to a number of orchestrators in the network and ask them to do a specific encoding job for them. The orchestrators would basically repeat with a price they would be willing to work for and a quality that they can produce. And the broadcaster would pick those orchestrators that he finds being applicable for his business model. So if it's long tail, you most likely are going to look for somebody who is like less expensive, maybe produces a less good quality, that's okay. If you look for peak content and you need like really high quality, you most likely are looking for an orchestrator that gives you a high quality estimation score and also like a good price for it, but you would be willing to pay more for that. And the broadcaster is really free to pick whoever he wants. So he's maybe asking 50 orchestrators to do the job for him, and from that 50 results, he's going to pick the one that's best applying to his job, depending on his personal needs. And the orchestrator doesn't know about this. The orchestrators also are all in competition among each other to broadcast a good price and a good quality to win the job. So by the broadcaster picking an orchestrator, they're basically agreeing on certain work conditions, and the broadcaster, he has to secure the necessary funds for the job in an escrow. And in case there's like a failure with the orchestrator, he would know that he would never have to pay for such a job. And the broadcaster can pick multiple orchestrators, so basically we have built-in redundancies in the protocol to make sure that even an orchestrator is going down, this would not interfere with your stream. Now, the orchestrator itself, it has a relationship to the transcoders, and the transcoders tell him what qualities they can produce, so it can just can use the information from the transcoders and distributes the jobs among them. So let's take the cryptocurrency miners example. So currently their profit margin gets really thin. We call them video miners, by the way. Currently with like an NVIDIA 1080 Ti card, you would only be able to do like 70 cents a day with hashing crypto, and only 10% most likely is going to be your profit margin, depending on how much you have still to pay for the hardware and what your electricity cost is. But at the same time, this card could potentially encode 2 live streams at the same time and into an adaptive bitrate asset. So, you know, if you buy these services, like rendering 2 4K streams at AWS, for example, you mostly are going to pay them like $3 per hour per stream to do this, like $144 per day, and not 70 cents. So what would a miner do if he want to like extend his profits by 10 times? What would he have to offer in an encoding network if he wants to do this? So he would only end up asking for $10 for a whole month to do the stream encoding on. and still would have 10 times the profit on it. So bandwidth is missing here. If you think bandwidth being the big bottleneck now for the miners, then you will see that pricing for bandwidth is also completely depending on where you are. We saw it ranging from 10 cents per megabit per month to like $10 and even higher, really depending where you are. And miners will have to, similar how they previously tried to find really affordable electricity, they will now have to find affordable bandwidth to contribute to such a network. So, but if it is about $1 per megabit that they would have to pay for such a task, and we estimate with like 10 megabits per stream I/O, then these numbers would just double for a single stream to be produced. So miners could potentially sustain a few magnitudes of the current worldwide encoding demand. Like Twitch, for example, they have only running like 55,000 concurrent live streams on their whole platform. And you can be sure that only a fraction of these even get a transcoding, only if you have like more than 50 concurrent viewers on your stream, or if you have, if you are part of their partner program, only in these cases you would get a transcoder from Twitch. For their long-tail customer, they don't really do it, and that's a problem, right? If you can serve to your first viewer because you're sending 1080p 60 and he has only a 1 megabit connection, right? You're missing out on your first viewer, and it's like impossible for a smaller audience then to grow. So the miners, in a sense, could now take care on this, do it for a fraction of the cost, maybe at a lower quality, and basically the platforms themselves can just redeem them with paying them for the encoding job. So still there's like a cost to cover, still there's like hardware that somebody has running somewhere and is asking money for it. How about if it's really possible to outsource it completely to the user side? Platforms that try to build a really engaged audience are experimenting with these things. They're trying to find ways how they could return digital goods in return of like a service that you do in the network, like tagging content or sharing your resources like bandwidth or encoding capacities. So in the end, if it's possible to build a network that runs completely on the user side, it also means it has a chance on running at a zero marginal cost. You could basically keep scaling such a system without, adding more and more on the infrastructure for it. So transcoding is only part of the workflow, and that's what we take care on with Livepeer. But if you look at the landscape, you will find for nearly all the necessary parts that are needed, the components that are needed to build a video platform, you will find replacements for them. A few examples that we could talk about here is, for example, storage, which is like one of the key problems we have. Like many people think it's delivery, but no, delivery is going to be easy. With delivery, we see peers becoming more and more powerful over time, and at a much faster speed than storage would ever be. So we, for example, think that for the delivery, peer-to-peer is really a silver bullet, and it's just a matter of time that there's enough density of high bandwidth users in a network, so a peer-to-peer network could solidly, or not solidly, but it could run at a huge percentage on peer-to-peer delivery and only would use a CDN then as a kind of mid-gress tool to always help out when peer-to-peer is not available. And there's already centralized offerings that do that really well. For example, Peer5 or Streamroots at the last World Cup, they took over like 80% in some cases of the actual CDN delivery and pushed it to the peers. So yeah, I think that's less of an issue. But storage is an issue. Proof of replication is a mathematical problem that hasn't really been 100% solved yet. But there are very interesting projects out there like Swarm or IPFS or StoreJ that are having a similar approach as we do. They're not only trying to have it outsourced to the users, but they're also trying to include industrial resources, data centers who have spare capacities and could just contribute to such a network. Yeah, you have accounting. That's the beauty with us, right? We do not really have to run a separate content management system. In a sense, the blockchain is helping us to validate content and to store it in a public ledger. There's analytics. Analytics is also really interesting because it boils down to the privacy problems. So many of these new companies, like DataFund, for example, tried to build ways how users could, share their data with their platform or have it encrypted and secured from using it there. And this all in a GDPR compliant fashion. It's kind of amazing. Paywalls is similar. With paywalls, cryptocurrencies are just helping there immensely. We have already working micropayment systems that do not tax too much on the actual financial infrastructure layer. So with most of the paywall layers out there, you have to pay a huge percentage of the actual income of your online tickets to the payment processors. And with cryptocurrencies, you just don't have this. There's always going to be a transaction fee on it, but that's most likely is going to be very, very small. So I think that's it. Thank you very much.